Number 70? Yeah, okay. Ooh. So what's the first thing you want to do, or that you want to make sure you do somewhere soon? Yeah, so this is a division of fractions, so I know I have to multiply by the reciprocal. Even if there's letters in there, it doesn't change anything. Now, so this is going to become times 2a plus 3b over a minus b. And now, and neither one of these are factorable, right? There's no squares in the letters. There's only one of them. I can't cut them in any parts. This part's done. It's just sitting there. But this I can definitely. Both of these are what? 4. Difference of squares. 11. Right? So then you can just factor both of those. I don't know. Where was the? Who asked the question again? Where was the issue? Did you get to this point?
Yeah, I got a plus b.
Okay. A plus b. A minus b, right? And what'd you get on the bottom?
I gave up.
Oh, shit. So why'd you put A there? Because there's 2 a's, right? There's a times a. So you split it up as a. This is b times b. You split up as b. Well, what's 4a squared? Cut it in half. 2a. 2a. Doesn't that make 4a squared when you multiply? And what's 9b squared? 3b. Bam. Yeah. And as long as you make it plus minus, I don't have to worry about the middle term because it's going to cancel. Everything's the same except the sign, so of course they're going to kill each other. Right? You get plus 6ab minus 6ab. Dead. So then it matches with this that has no middle term. Okay, maybe. And now you just go to town and just kill. If you don't like violence, you can say cancel. If you enjoy killing expressions in mathematics, then you can say, I am going to kill you. So what dies?
2a plus 3b.
Yeah, the 2a plus 3b dies.
A minus b.
A minus b dies. So who's left alive?
A plus b over 2a.
And again, if you made a and b any number you want them to be, except some number that would make the bottom undefined, right? So here, you see that's on the bottom, so then this, you can't let a and b be the same number, for example. But if you let a and b be anything else, almost anything else, this would be a fraction divided by a fraction. When you do that problem, it would come out to be this. Okay, I don't know if I want to do that right now, but we've done that kind of thing before. And that works for every value of a and b that doesn't make this undefined to begin with. Right? Every value of a and b would make that happen. It's crazy. Do you guys want to see that or no? You want to see what I'm talking about? You're like, dude, I don't want to see most of what you show me. I'll be all right. Okay, all right. Anything else from homework stuff?
From 73, number 55.
Oh, okay, good. You're good. This is perfect. Can somebody tell me, this is related to this problem, but it also shows up earlier. If I had a minus b over b minus a, is the top the exact same as the bottom?
No.
No, so they can't cancel directly. But the top is related to the bottom, right? And remember, the whole idea of simplifying, and then I'm going to tie it into this problem. The whole idea of simplifying is factoring and then seeing what's the same. So what can you take out of the top, for example?
-1.
Yeah, -1. So now the b becomes positive and the a becomes negative, and now you see, bam. Are you guys with me? Because if x minus y is positive, y minus x is going to be negative. What's 7 minus 3? Well, what's 3 minus 7? -4. That's why when you take the ratio of two things that have just been turned around, the answer is -1. They're going to be offset by a -1. I like it. So what the hell does that have to do with this problem? You're being so patient over there, like, I didn't ask that shit. Which one did you ask again? The number 55. Wait. So this is 7.3. So here, are the denominators the same? No, they're not. But again, what separates the denominators?
-1.
Yeah, there's a -1 factor that somebody's missing. So if I multiply either one of them really, but why do you think I would multiply this one top and bottom by -1? Because that would kill that negative, right? But if you did this one, you'd actually get the same answer, even though it would look different. Yes,
If you'd be multiplying the top and bottom by
you have to, right?
by -1, how come the top thing, the thing you explained first, you didn't do the bottom?
Okay. This problem leads you to the idea of this problem. But did I change the fraction? No. I factored one of them so I could see what was common, right? I didn't multiply one of the things by something. I took it out. It was already there. I didn't give anybody something, so I didn't like break a rule because I didn't give the other guy something. It was already there. Here, I got to give him something he ain't got, right? This is beautiful grammar, by the way. So you got to multiply top and bottom by -1. So now you get 5 over x minus y plus 5 over
X minus Y.
x minus y. Because now the negative times y is negative y, -1 times negative x is positive x. That kicks so much ass. Now there are multiple ways to do this problem. Some of them much longer than others. You could give this guy this and get this guy that. Oh my God, it would eventually work. Right? But they're not missing each other. Just one of them is missing a -1. Now another way you could do this, just to show you, more related to what I did up there. And again, the thing to realize with this is the main idea. I'm always trying to make the bottoms the same. And I'm always trying to do everything I can as easy as I can. That's the two things that really rule math. I need the bottoms the same. They're almost the same. Why aren't they the same? One of them's the negative of the other one. Well, shit, let me just turn one of them around. How do I turn them around? Multiply by -1. Right? Another way to look at that same problem, that's sort of related to that one, is how do I factor the bottom of this one? I can take a -1 out, right? So then the x would become positive, the y would become negative, and then these negatives would cancel. And that's exactly what I'm at right there. Same thing. Okay. Is that decent? I mean, so the idea doesn't change. You want to get an LCD. And if you multiply this by this and this one by this, you're not wrong. You're just, it's not really the lowest common denominator. You're just doing a little more work than you need to. Anything else from homework stuff? What's homework stuff? Stuff that's for homework? Yeah. No. Okay. All right. I'm an optimistic fool, so I just say that means most of you guys are having a good time with homework. Okay. So last time we actually made it through 7.5. So, real quick, let's do a couple examples from 7.5. Just to remind you guys, Monday, I have a quiz. It's going to be Appendix D, so synthetic division. And there more than likely will also be a long division problem on there also, right? Through 7.2, I think I said. So that goes up through just multiplication and division of rational expressions, right? So you might flip one and factor it and kill everything that's common.
What homework assignments should we have ready by Monday? Like up to what section?
So yesterday we finished 7.5.
Yeah.
So then Monday you should be done or close to done with 7.5.
Okay, just making sure.
If you're ahead of that, kick ass. Doing great. If you're already ahead of that, holy shit. Really kick ass. Yeah.
The test is on Wednesday, right?
Mm-hmm. So today I've got the practice test. I decided to go ahead and print it out for you guys. I'll have the answer key on Tuesday. So Tuesday we're probably going to be finishing up chapter 8. And then the rest of the class will be devoted to review for the test. So I'll have the answer key for the practice test.
There's no schools on Friday, right? Not for this class, but overall. There's no schools.
Yeah, the over the summer they do a 4-10, which means the staff are here for 4 days, 10 hours each day. So still 40 hours. And then Friday they just shut everything down to save money on energy. Yeah. Cool. I like it. Okay. So here's what 7.5 was about. Part of it starts off nice. Let me give you one that's... Oh, and let me do this. Let me give you one that's a little bit different. What you got, Jeff? Let's just take one from them. Yeah, that's great. Of course, what makes this a little grosser is the fact that they're mixed numbers. We did a problem last time that they weren't mixed and it wasn't that bad. So obviously the first step here is to do what?
Can you try and get them the same denominator and then cancel it out?
No.
To make a 2 times 3 plus 1.
Yeah. So I want to make them improper fractions. Now, because what does this really mean? This is one of the most evil decisions in history, is to write this like this. Because what does this really mean?
5/3.
No. I mean, what about 1 2/3? What's the and? 1 and 2/3. It's not 1 times 2/3, because then this would be 2/3. That doesn't make any damn sense. What is the actual operation that we're not writing in the middle? Plus. And division does not work well with addition. Do you guys understand? So, is that cool? So that's why if I make them both improper fractions, I ain't got none of that plus crap floating around. I can just attack it directly. Let me let that sink in. Okay? So yeah, when you get here, when you do improper. And then this will be 7 halves. So 5/3 divided by 7 halves is 5/3 times 2 sevenths. Nothing's the same, so I just get... Cool. And remember, you do not need LCD when you multiply or divide. Multiplication division is not nearly as strict on like terms. X times x squared is x cubed. Even though x and x squared are not like terms, addition, subtraction can't handle them, but multiplication can do it all day. And LCD is just the same thing as like terms. It really is the exact same thing. I don't need that shit here. Okay, maybe. So that's one level, is going to have no variables in it, right? Of course, the next level will have variables in it, and I can even go to this level. Yeah, sure, let's do that. So there are multiple ways of doing this problem. You just have to pick the way that makes the most sense. Now, the way I showed you the first thing I showed you yesterday was based on making it look like this so I could do the same thing. Which kind of makes sense. It's kind of nice to just go, let me just make everything work the same as much as I can, so I got less to kind of remember. So one way you can do this is to tackle that problem. Same thing we did here, to be honest. Isn't this a mixed number? Mm-hmm. Right? Those are mixed numbers. So let me combine them so they can become... And actually, to be honest, real quick word. That's just a thing for you, Jeff. I know. Shit. Isn't that 1 plus 2/3 on the bottom? On the top, right? So 1 would be 3/3, right? I think I showed you this before already. And then you get 5/3. And so this 3 times 1 plus 2 is really just a shortcut, right? Here, these are freaking variables. I don't have a shortcut for that stuff. Too bad for me. I sort of do, to be honest, but no, let's not go there. So how do I do this? If I look at this problem, the top is a problem, how do I do that? What's currently under this dude? A 1. So of course, what's he need? Another x. All right, so on the top I get x squared minus 1 over x. Is that cool? X squared minus 1 all over x, because I made the bottoms the same. Here, the same idea. So for 1, he needs another x. So on the bottom, I'm going to get x squared plus 1 over x. And now you can either go ahead and multiply by the reciprocal, right? Or like we did yesterday, some of you guys realized the over x's just cancel. So either way you do it, you do it this way. Multiply by the reciprocal. Those go away. Can I do anything else here? I could factor the top, but can I factor the bottom? So they can't have any factors in common, right? And you definitely, sure as all hell, cannot cancel the x squares. Please. You have to totally understand that. It hurts me if I ever show you doing that. It hurts me physically to cross them out and say, don't do that. Get a little... Hopefully you guys understand. Because division can't cancel parts of addition and subtraction, period. It's just not its thing, it does. The top factors, but the bottom don't. So I'm not going to waste my time. Right? It's like having 9 over 17. I can factor the top, but who cares? The bottom's freaking 17. I'm not going to try to reduce that. Okay. All right? This is hopeful Tai Chi I've decided. Okay. Let me think. They don't get too much worse than that. They get a little worse than that. But not too much. So again, I just got to wait till you guys get into it so you can bring me specific questions. You have?
Yeah. When is it, like for number 4 to the right, x over 2 divided by 1 over x minus 1?
Oh, yeah. So I could write this as 5/3 divided by 7/2, right?
So that's all that's...
So if they gave you this, I could write it like that instead. So it's just making the division, the divided symbol like this, become the big bar symbol. That's all it's asking you to do. Yeah. Just to make sure you really understand that these are the same thing. Cool. I like it. Cool. Okay. So anything else from that section before we move on? Summertime. Oh my God. It's flying at you fast. All right. So it shouldn't be too surprising that the next thing we do, we've investigated the hell out of rational expressions. We added, subtracted, multiplied, divided them. We simplified freaky-ass versions of them. At some point, we're going to have to look at equations with them in it. Because that's the bread and butter of algebra, solving equations. So let's start off with an example equation that's only got numbers on the bottom. Just to remind ourselves how that works. So everybody got what they want here? More than you ever wanted. Okay. So somebody help me out. I think we did one like this before somewhere. This is 7-6. What you got, Joe? Sure. Actually, I should have really. Let me do a little side note. Here's a problem that should be really easy, but just to make sure. And again, I shouldn't say that, but x over 7 minus 3 over 7 equals 2x over 7. Why is that problem just desperately easy? Yes. You can immediately kill the part that makes it look gross. Everything's being divided by 7. And it's an equation, so I'm allowed to multiply both sides by anything. I can multiply both sides by 2. I can multiply both sides by negative 18 billion. I could. I'm not going to. I'm going to multiply both sides by freaking 7. Does that make sense? So I multiply everything by 7. I had x, that 7's cancel, 7's cancel, 7's cancel. X minus 3 equals 2x, so x equals negative 3. Bam! So why is this problem a little bit worse? Because the bottoms aren't the same yet. So of course my first step is to make them the same. Find the LCD, right? So what is the LCD for this?
7.
Well, that's the number that kind of goes into everything. What's the LCD? What can everything become? 28. What does he need to become 28? 2. He needs nothing. He needs 4. Cool. I like it. And these are all he's. I won't get into the biology of that. So this will be 2x over 28 plus 3 over 28 equals 20x over 28. And then what could happen? Some new markers. What can you do now? Now we got all the bottoms the same. We can just multiply both sides by 28. What's making this look gross is all the over 28s. Well, now watch, real quick. If I multiply both sides by 28, I would distribute the 28, so I just put a 28 next to each term, just to get to the point. You guys see that? Do you guys see that? So if I have to multiply both sides by something, if I want to multiply, and if I multiply this side, it would distribute, so just put it next to everybody. Now I feel really bad for the people that multiply 28 times 2 and 28 times 3. Why would you do that? What immediately happens? Yeah, they die. There's no 28s. So now look at your equation. It's 2x plus 3 equals 20x. That kicks so much ass, right? What do? Subtract 2x. 3 equals 18x, and I love, just to save you from yourself, the answer is not 6. Right? Yeah, you divide by 18. Don't let your brain go, I got this. Say, no, brain, you ain't. Let me write this shit out. So x equals 1/6. Cool. I like it. Okay. Now this problem, this is a really silly thing to say, but were any of the bottoms 0? No, it was freaking 14, 28, and 7. When I start putting variable expressions down there, could any of the bottoms be 0? Yeah, there could be places where there's 0. So we're going to have to, that somehow is going to come into play. We've got to be careful with the answers we get. Okay. So, what are the problems going to look like now? They're not going to look like that. That was too easy. They're going to look like this. What do you got, Jeff? But I want you to realize I've been sort of prepping you for this, to be honest. What we're going to do feels very familiar to what we did a couple sections ago. The first thing you want to do is exactly the first thing I want to do here, because I'm dealing with numbers in both of these problems. Here are just numbers I don't know yet. What's the LCD going to be over there?
X minus 4, X plus 4.
Yeah, you got to love this shit. There's got to be tons of hints in these problems. You just got to look at all the bottoms and go, I don't have to really factor anything almost. I can just see the parts for most of the problems. So who's missing something? What's this first dude missing?
X plus 4.
Yeah, so he's missing an x plus 4. He's missing a...
X minus 4.
Oh, poor little dude, you're almost dead. And he is not missing a damn thing, right? Okay. So, what do we do now?
Cancel out the denominators.
Yeah, you multiply both sides by that. So what we're actually doing right now might be illegal. We just don't know it yet. What the shit do I mean? What would make the bottom 0? What values would make any of the bottom 0? 4 or negative 4? Could x be one of those things? Yes, of course it could, because x could be anything. And maybe the thing that I find at the end is going to be 4 or negative 4. Would it be allowed to equal that? Because it would make one of these undefined, right? So don't get, I love students who get angry. They're like, why did math tell me the answer was 4 when it can't be? Well, math didn't know what to say to you here, right? We did something illegal. Are you allowed to multiply both sides of an equation by 0? Think about it. Even if nobody's ever told you that directly, do you think you're allowed to do that? If you multiply both sides of an equation by 0, you end up at 0 equals 0. You lose all your information. Are you allowed to do that? No. Right? So what am I about to do? I'm about to multiply everything by x minus 4, x plus 4. So if math gives me an answer of 4, it's saying, dude, there's no answer because what you did to solve it was illegal in the first place. So there would be no answer. The only possible answer makes it undefined, so there's no answer then. Will that always happen? No. But whenever you get the answers, you got to make sure. Does it freak anybody out? If it does, you got to throw them out. They're what's called extraneous solutions, which sounds painful, right? Sounds like a procedure at a dentist's office or something. You got to get it extraneous. Oh shit, no. So if I multiply everything by these, and this is where you got to be careful. Effectively, what happens is all these just go away, right? That's what happens. Just people get a little happy about that and just start crossing all the bottoms out everywhere. It's like, no. Careful. And what am I left with then?
2x plus 8.
2x plus 8
Plus 5x minus 1.
plus, good, 5x minus 20 equals x. I love it. So then you get 7x minus x is 6x. Then you get negative 12 add 12 equals 12. Is that? I'm just going to, everybody should be able to solve equations. I'm just going to do that a little quickly. So you get x equals, is that allowed?
Yes.
Yes. Did I just check the answer? No. I just made sure that 2 was an allowable answer. How do I check the answer? I'm going to plug it back in everywhere. Let me stop there for a second. Make sure this is recorded. Yay. So I like, that's not the only way to do this problem, but it's, after a lot of teaching and a lot of talking with people, this is the way that makes the most immediate sense, because it's related to stuff we've done before. Okay. So if you have a slightly different way to do this, do it, and I'll tell you if it looks okay or not. All right, so let me give you guys one to try. Try this one here. Oh, let's see. should come out to be a fractional answer. Like 41 over
3.
So do you guys start to see what I mean about hints in the problem?
Yeah, it tells you what it factors.
This is this times this. Just kind of double check and make sure it's not some extra evil problem, because the book does give a couple of those possible. So that times that is this. So then what's he missing? Nothing. What's he missing?
X plus 2.
And what's he missing?
X minus 9.
X minus 9. So then I multiply both sides by x plus 2, x minus 9. So they cancel everywhere. Cool. So if you first make all the bottoms the same, which is a skill you have to have anyway for an earlier section, you can then kill them because it's an equation. That's when you're allowed to kill things on both sides. And now I get 4x,
Minus 2x minus 4.
good, minus 2x
Plus 4.
minus 4. Negative 2 times x, negative 2 times 2. Shit, yeah. So remember, you can do this.
Yeah.
So don't forget that negative. Equals 5x minus 45, 11. And that was pretty quick to make it look a hell of a lot better. So now you get 2x, subtract 2x, you get 3x. Add 45, you get 41. So x is 41 over 3. What makes the bottoms, any bottom 0?
9 and negative 2.
9 and negative 2, and that is neither one of those. So at least in that respect, it's an allowable answer. Okay. Okay, I like it. And real quick, I get, when you're a student in an algebra class, you got two things going on in your head. You're like, okay, I kind of start to understand this, and then the other part of your head is, what the shit is this all for? And, that's always a good question. But so many things in life, like how if you're going 80 miles an hour in your car and you have 320 miles to go, can you figure out how long it's going to take you to get there? Can you guys do that? We got to go 320 miles, and I'm going 80 miles an hour.
So,
How long would it take me to get 4 hours, right? Distance equals rate times time, dirt, the D equals RT equation. So ratios show up all the damn time in the real freaking world, right? So this is some kind of an equation that could actually come up from anything that would have ratios involved. Okay, maybe. In fact, in this section, there are going to be some, word problems that you're going to have to figure out, and they're related to real life stuff. Okay. So let me show you this. This has come up before in this class, and this is the one you got to be careful about. Good old cross multiplication, right? So if I have something like this, which gotcha, 3 over x minus 1 equals 5 over 2x plus 7. I like it. I'm going to do this the long-ass way to show you why cross multiplication is a shortcut. So if I attack this problem the same way we did this problem, because this method works, obviously. We've used it a few times. What is this guy missing? 2x plus 7. Of course, this guy's missing x minus 1. And then I could cancel the bottoms, right? I could multiply both sides by this, so they would go away. So what does it look like happen? It looks like that comes up here, and it looks like that goes up there, and that's where the word cross multiplication comes from. So it's just a shortcut of the same thing we do. Why couldn't I do it here? Because there's fraction plus fraction equals fraction. Oh shit, it's just who would go where? Oh shit. Maybe. So because the equation has less parts to it, there is a shortcut method I could use that actually just comes off of this method anyway. Maybe. So that's the only place you could use cross multiplication. So just to write it better, again, so I had 3 over x minus 1 equals 5 over 2x plus 7. The shortcut is, that goes up here. What's 3 times this?
6x plus 21.
6x plus 21. That goes up there. What's 5 times this?
5x minus 5.
Now, for some reason, I get a lot of people take that up there and take that down there, and they end up with the one thing, one fraction, and they're like, I don't know what to do from here. And I'm like, I don't know what to tell you either. What the hell happened? You can't lose your equation. That's got to go up to that side. That goes up to the other side, so you still have an equation there for yourself, right? And now this is easy. Subtract 5x, you get x. Subtract 21 equals negative 26. Bam! And again, what makes the bottom 0? 1
Fraction.
or subtract 7 divided by 2, negative 7 halves. And that's neither one of those, so it's a valid answer in that respect. Okay. Oh, and then there's one last kind of special case you got to be careful about. Oh, let's do this one here. I like this one. Yeah, looks gross. Now, for some reason, people see that this guy has no bottom and therefore I don't have to worry about him. That doesn't make any damn sense. Everything has to have the same bottom, and then you can do what we did earlier. What is currently underneath there? Yeah, it's going to need a lot of shit. Now, the other level of a mistake on this problem is, don't write this down. I get somebody to do this. Yay! And now some of you guys might be going, that looks good to me. What the hell? But that is pure shit. If you think you can do that, then you think 1/2 equals 2/3. Hell, if you think you can do that, then you think 1/2 equals 0, which is even neater. Right? Because then you're like, I can just subtract 1, 0 over 1 is 0. There you go, Jeff. You know, I owe you $500,000. No, I owe you nothing. Mathematically proven. No, bullshit. Right? What's the only thing you're allowed to do top and bottom of a fraction is multiply or divide. I can't add or subtract something from the bottom, top and bottom. It doesn't make this number stay the same. So no, get out of there. So he's got a y plus 1.
He needs y.
He's got a y. So yeah, he needs y. Now he's already on that. He needs a y. He needs
Y plus 1.
y plus 1. And this dude needs both of them. Shit. Right? He needs a y and a y plus 1, so he has the same bottom. Got it. All right, let me let all that sink in. So we just did, we're not done with this obviously, but we just did 3 problems that a stronger student in mathematics would say they're all the same. And they really are. They're exactly the same problem. All the 3 problems we just did, the same problem. There's nothing different about any of them. Right? And if you have more trouble in math, you're somebody who says, well, they're each a different problem. I got to memorize a different procedure for each one, and that's why you feel like, how does anybody know math? There's so much shit to remember. No, there isn't. There isn't that much holy shit. Right? So not every problem is different. They all have this fundamental thing that's similar between them. What can I do now? Yeah, I made them all the same. I can multiply both sides by this so they'll cancel. So now what do I have? 6y plus
6y plus 6.
6y plus 6 equals 5y squared
Plus 5y.
plus 5y. Now take a minute and see if you can solve that. Now I leave you out to dry. Oh, So make sure everybody's on the right track. What method do you have to use to solve this?
Factor it out.
Factoring has to come to play
The
because, well, surefire method linear grouping, because of that y squared term, right? So you got to get it equal to
Zero.
0. And then that piece right there is what tells you what to do.
And would we just solve to like see what values are zero at that point?
So again,
Once you factor it all out, you just solve to see what would be zero. And that's
yeah. Once you factor it, you set each piece equal to 0.
Right, yeah.
Yeah. So then if you subtract 12y, subtract 6, you get 5y squared minus 7y minus 6. Oh shit.
And then 10 and positive 3, right?
Yeah, so because what do you do?
Surefire.
Yeah, whatever you call it. Yeah, master product, surefire, AC method, the negative 30. And we've seen this a few times. Yeah, it's got to be negative 10 and 3. Are you guys cool with that? You guys see that? So, I mean, the idea of how to factor this doesn't mean you only use it when the problem starts off like this. The problem could eventually lead to something like this, and then you have to know how to do it. So it's a tool I use whenever I need to. So then I got 5y squared minus 10y plus 3y. That's what that is. Bam. Minus 6. Then you group. Come to 0. You got 5y plus 3 times y minus 2 equals 0. Okay. So either y is negative 3/5 or y is 2. Again, if you need to, you can write 5y plus 3 equals 0. Solve it. You'll get negative 3/5. Or y is 2. Does either one of those make a problem up here? Does either one of those cause an issue up there? What would cause an issue if I get y equal to negative 1
0.
or 0? And I didn't. So I'm good. Now if you did, real quick, if that was 0, I would cross it out. Right? It's just not allowed. It's the same thing as, the good old word problems. You're like, I want to build a shed, and I want the length to be 2 more than twice, and you get a negative answer. Well, no. So the math is like, this number works. And we're like, well, this is a real-world problem, and I don't know how to make something at negative 2 length, unless it's some freaky black hole shit. I don't know, right? Negative 2 length. Don't get too close to the shed. It's not good. But here, this is a different idea. If I get y equals 0 or something, it's just not allowed. I can't it makes the equation undefined, so it wouldn't be an answer. Okay. Let's do one more type of problem from 7-6. What time is it? I don't have my... Anybody know what time it is? Like 12, 10 past 1. So, all right. So we'll do one more thing, and then we'll take a break, and then we'll get into chapter 8. All right. So here, right away, is this thing I was talking about earlier. Distance equals rate times time. Dirt, right? And you all know this already. I mean, if I'm going 20 miles an hour for 2 hours, how far did I go? Not very far. So yeah, if you're trying to go home, if you're trying to go to the beach from Grossmont at about 3:30 p.m.,
5:30.
that could possibly very well define your movement, right? You know what I'm talking. There's certain times of the day I've learned, after being here for a while, that you're like, is that time? You just stay where you are for a little while. Might as well just stay here for a while. So we know that 20 mile an hour times 2 hours will tell me how far I'm going. That's just what that equation captures. So this kind of word problem, let's see, this kind of word problem that shows up in like Far Side comics and all kind of stuff. The train leaves Wyoming going 40 mile an hour due east or something. So here's a problem we're going to look at. Let's see. Blah, blah, blah. Let's get one that's not too freaky. Ooh, that's freaky as hell. We'll try that one next. Let's see. Yeah, that'll be all right. Yeah, okay. So let's say we got a boat and a river, all right? And the current is 6 miles an hour. So anybody go kayaking ever? Like kayaking? Anybody ever watch kayaking on TV? So if you're kayaking down like in the rapids, right, where it's coming at you fast, you can get to a point where you're paddling as fast as the water is pushing against you, so you basically stay in the same place, right? So if the river's going 6 miles an hour, and I'm going against it at 6 miles an hour, somebody on this bank is going to be like, well, you ain't getting nowhere. I mean, he's sitting in the same spot, right? Does that make sense? So it seems that however fast I try to push my boat or get my boat going, I'm going to have to subtract 6 if I'm going against it. But what if I'm going with the current? I'm going to add. So it's sort of related to anybody ever fly across the country and come back and you're like, why does it take longer one way than the other? Because you're going with and against the wind, possibly, depending on where the plane is. You guys with me? With the wind, against the wind. It's going to take longer against, obviously. All right, so we have a boat in the river. The current 6 miles an hour. Now I've totally forgotten what the problem is. Blah, 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 blah. Where'd you go? Here we go. It can travel, our boat, we'll call it boat face. No, we'll call it boat. Boat can travel 114 miles upstream in the same time, same amount of time it travels. Where'd you go? 186 miles downstream. Now, why does that make sense physically? Yeah, if I'm going with the current, I should be able to go further in the same amount of time as I would going against the current because I'm going faster from with the current. Okay, cool. So on one level, this problem is like, well, no problem. But now I want to get specific. Now I want to know what is the speed of the boat? What speed is the boat going by itself without the current? Okay. So any word problem, you have to first pretty much identify what x is. All right, so what is it that I'm looking for? I'm looking for the speed of the boat itself. So I'm going to call that x. Become a b. Okay. So here is one way to do this kind of problem. If you have a different way, you can do it that way. I kind of like this way because it just sort of starts with just organizing things and then you worry about the equation. I have two situations here, right? I have upstream and downstream. And I have an equation, rate times time equals distance. Does that equation give a shit about if you're going against or with the current? No, it's going to be true. It's the true equation. So how fast is the boat going if it's going upstream against the current? It's trying to go X mile an hour, right? But how fast will it actually end up going? Careful. So I'm going upstream against
X minus 6.
X minus 6. Are you guys with me? Okay, so remember, if I'm going 6 miles an hour, I'm actually not going anywhere. I'm like, okay, shit. I'm going to need a bigger engine. Right? So whatever's trying to go, whatever I put it at, it's actually going to be going 6 miles an hour less because I'm going upstream, going against the current. So what's the rate? What's the rate of travel going to be for downstream? It's going to be X plus 6. So this is like a boat for an attraction somewhere, and it actually has you can't speed it up or slow it down. It's got like one speed. You turn it on, it goes, and it just starts going that speed. You with me? So don't think, well, I could have just like speed it up a little. No, it's just It's just got that one speed. X is that speed. Right? So against the current, it's going to be going a little bit less. With the current, it's going to be going that much more. Like if it's going sideways to the current, it'd be going X. Actually, it'd be going that way a little bit too, but oh well. Now, how far? Now, it's almost always when you do it this way, you're going to have boxes that you just know exactly what it is. Upstream, how far do I go? 114, right? The distance they go upstream is 114. The distance they go downstream is
186.
186. I like it. Now, if rate times time is distance, right? How do I solve that for t? Because t is what I don't know. It's the blank boxes. I got to know what that is. I got to figure out what that is.
Distance over rate.
Yeah, rate times time is distance. Good. Time is distance divided by rate. So here, what am I going to put? Distance divided by rate.
114 over x.
114 over x minus 6. Again, distance divided by rate.
186 over x plus 6.
I like it. Now, the equation comes from something that's a little hidden sometimes to students.